This is Devansh Agrawal, and we are here to design and implement an effective distributed load balancing algorithm in fog network. So the domain here is networking and subdomain is fog computing. Now we are having a cloud and IoT devices, and fog network will act as a bridge between the IoT device and the cloud. So we are having multiple fog nodes connected to each other and at last connected to the cloud. Now, let's take the self-driving car as an example. Consider the situation in which an object came in front of a car and now the car needs to decide what to do. During the time it will take for the sensor to send the data and for the cloud to process and send it back to the car, telling the car that it needs to stop. There is the possibility that the car will collide due to the high latency. So to avoid the situation and with the ever increasing number of IoT devices and latency constrained applications, it is essential to move away from cloud computing and towards processing requests closer to the end user, that is fog network. Furthermore, as the volume of data is exponentially increasing in IoT networks, it is inevitable to design an effective load balancing algorithm to distribute the load across fog nodes in a fog enabled IoT network. So here we proposed a Q-learning based dynamic load balancing framework for fog enabled IoT network. So our objectives are to minimize the overloading of fog nodes, to make an effective dynamic overloading decisions, to determine the number of tasks to be offloaded, and to minimize request processing time and hence its latency. So here the data set we are using is taken from the campus itself. The data has been taken from multiple sensors that you can see here. That is the temperature sensor, humidity sensor, air quality sensor and carbon monoxide sensor. The data is taken in a tabular form and you can see the demo here of the data. The architecture design is like this. Multiple fog networks, that is termed as servers here, are connected to each other in a mesh topology and further it's extended to cloud. Every server is having IoT devices which is sending the data to the server and which is further deciding how to process its data to get minimum latency. The reward function that we are using here is tanh, and the graph here is this. Now, as we can't predict the number of packets in the real world that is arriving to the fog networks and we can't take it mean. So here we are using the Poisson distribution for guessing the number of packets that will arrive to the fog networks. And the graph that has been plotted according to which we are taking the Poisson distribution value as the arrival rate is this. The Q table after exploration and exploitation and during exploitation is this. Now we are having three different states. The state 1 is between 0 to 0.4, 0.4 to 0.6 is the medium state, state 1 is the low state, and state 3, that is from 0.6 to 1, is the high state, means overload state. And actions are represented in the x-axis that you can see. 0 means offloading to itself, 2 means offloading to the fog node 2, 3 means the offloading to fog node 3, and 1 2 means the offloading to itself and fog node 2, and so on. According to that, the Q value has been given in y-axis. So after implementation, the results graph here it has been represented. So now first graph is according to the number of iterations and the rewards in lower state, that is 0 to 0.4. Now the reward value for number of iterations to the reward in medium state is the second graph shown here. The third graph here represents the number of iterations to the reward value, and the fourth graph shows the delay of the processing of the packets. In some time we will even look the implementation part. Let's go with this right now. Here the action chosen and the number of iterations it's shown in graph 1 and 2, in different states, we can clearly see that for first some iterations during exploration, random actions has been chosen, and according to that q values have been obtained, after which in exploitation part we can see that we are getting the linear graph. Means in exploitation it is choosing the best q value that will give the minimum latency, and according to which it is sending the packet and taking the actions. Here is also the action taken in the low state. Now the implementation part. So here we are having the server 1, that is fog node 1. Here we are starting it. The code we have written in Python, which is the code of OS. Here we are even using parallel computing, and basically we are using Q learning. Now let's say that it will be according to Poisson distribution, but here let's say that according to Poisson distribution it is sending 890 packets to server 1 because it's the client of server 1. So you can see that client 11 is like a IoT device that will send its data to server 1, and it has sent 890 packets. Now for first 1000 iterations the fog network will explore and update its queue table, and you can see even in fog node 2 different number of packets are been sent here, and according to which it will be processed, and the d value, that is the reward value, is being sent to the client that has sent it packet. So according to that reward value that is sent to the fog node, it is deciding the q value. We are even having the server 3, that is node 3, and it is basically exploring, taking different random actions and sending the packets to different nodes. And it's like if a node is sending some packet to another node, then their q learning will not be applied, and it will directly go to the system queue for getting processed. But if a packet is coming from a IoT device, then firstly according to q learning the action will be taken to distribute it according to the latency and minimum latency, and then it will be processed now. So the d value is the reward that is being returned from different nodes, that is telling that you were correct, how much correct, or you were wrong, and it is like a reward or the punishment given that it is right or wrong. You can see the queue table here that is being constantly updated. So this was our project, and after 1000 iterations, when more number of packets will be sent, then it in place of taking random actions, that is exploration, it will exploit. It means according to maximum reward value it will decide that this action will take minimum latency, so it will send to according to that action. Thank you.